Have you ever wondered how computers can detect edges in images? Well, the answer lies in a fundamental concept of mathematics known as the derivative theorem of convolution. To understand this theorem, imagine two functions. Call them function f and function g. The convolution of these two functions is another function that combines the characteristics of f and g. Now, the derivative theorem of convolution states that the Fourier transform, a mathematical tool that breaks down a function into its constituent frequencies, of this convolution is equal to the product of the Fourier transforms of function f and function g. But what does this have to do with edge detection in images? In the realm of image processing, edge detection algorithms seek out regions in an image where the intensity changes rapidly, a clear sign of an edge. A common way to achieve this is by convolving the image with derivative filters, specific mathematical operators that highlight areas of rapid intensity change in various directions, by Standovasos. By utilizing the derivative theorem of convolution, we can compute the convolution of the image with the derivative filter in a more efficient manner. This is accomplished by leveraging the properties of the Fourier transform. The result? Significantly faster computations, particularly for large images. In simpler terms, the derivative theorem allows us to perform edge detection by convolving the image with derivative filters in the frequency domain as opposed to the spatial domain. The benefit is quicker computation without sacrificing any information about the edges in the image. So, to sum it up, the derivative theorem of convolution is a powerful tool in the world of image processing. It provides a more efficient way to compute the convolution of an image with derivative filters, thereby speeding up the process of edge detection. By understanding and applying this theorem, we can better analyze images and detect edges, paving the way for more sophisticated image processing techniques. Understanding the derivative theorem of convolution is not just a mathematical exercise. It's a key to unlocking faster and more efficient image processing. So, next time you marvel at the edge detection capabilities of a computer, remember the derivative theorem of convolution and the critical role it plays.